Thank you so much. And thank you so much for inviting me. It's such a pleasure to interact with folks at University of Florida, and it brings back some really, really nice memories of attending Tropilunch and hearing a lot of very, very interesting things over there. So I'm gonna talk today about, first of all, I'd like to say sorry about the technical issues. Like I said, we had some rains over here, and I think that's messed up our internet connectivity a little bit. There were a couple of videos that I want to share, but I think the photos will show the same thing fine. Could you please go to the next slide? So previously when I've spoken, last time I was talking to students at TCD, I spoke about community-based conservation and about people-nature relationships. But this time, Patricia, could you please go to the next slide? I thought that we'd switch gears a little bit, and I would talk about animals that inspire something in us, basically charismatic animals, large megafauna, like, Patricia, could you go to the next slide? Like the Asian elephant over here that you're seeing. And this is the species that I'm going to be talking about throughout the presentation. Or next slide, please. The leopard that you're seeing over here. So these are species that for some reason or the other have captured our imagination. And for some reason, we have some sort of deep-seated connection with. So but I start talking a little bit more about these species, I'd just like to take a step back. Next slide, please. And just set the context a little bit. So most of the work that I do is in India, which is a crowded and aspiring country. We are 1/3 the size of the US, but we have more than 4 times your population. So we are 1.4 billion people. We also have a lot of cows, a lot of cattle, a lot of goats and sheep. We have more than 500 million livestock, the largest cattle population across the globe. We are also an aspiring economy. So we have a $3.7 trillion GDP, and also a growing economy. So our PPP GDP per capita is about $9,000, but we aspire to grow more over the next few years. At the same time, there is a very close dependence of people on forests and forest ecosystems, natural ecosystems. It's estimated that about 300 million people in India depend on forests. This is likely an underestimate. Next slide, please. At the same time, alongside all of these people, 1.4 billion people and 500 million cattle, are a lot of animals. We are a mega diverse country. We have a whole lot of different species. We have a lot of endemism, especially of amphibians and reptiles. We have 4 biodiversity hotspots, one of which is in the Nicobar Islands, and one of which is in Northeast India, where I work. About 25% of our area is recorded as forest. Now, this includes any woodland area, essentially. But we have a target, an ambitious target of 1/3 of our area being under forest cover. And importantly, alongside 1.4 billion people are also tigers, elephants, rhinos, leopards, and species that otherwise you wouldn't think would live in near where people are or in people's backyard. Next slide, please. So how does this happen? How is there this juxtaposition of so many people and animals such as elephants at the same time? A very, very strong reason for that is because of strong religious and cultural ties that people have to animals. You can see in the bottom right over here is a picture of an Indian god, which is depicted as, which has depictions of at least 2 animals over there. So there is an elephant and there is a raptor species, a vulture, I think. So there are very clear connections, both religious as well as cultural connections that people have with animals. Like I said earlier, there is also very, very close ties that people have to nature in and of itself, because there is high dependence of people on forests. There, a lot of people depend on forests not just for their livelihoods, but also for their day-to-day living. So it's estimated that about 85,000 tons of firewood is used annually. And this is for cooking, so basic means of cooking and warmth. There is also a pretty large NTSC market. And next slide, please. What is happening at the same time is that we are losing forests, and our forests are not only getting lost, they're also getting fragmented. So if you take a species like the elephant, which is a wide-ranging species, it's estimated that about half of the elephant range is in fragmented areas. If you take the average size of protected areas in India, it is about less than 300 square kilometers. For comparison, the average size of an elephant herd is about 250 to 270 square kilometers. So clearly, these protected areas are not large enough to hold a viable population of these kind of species in and of itself. And movement of animals between protected areas is clearly very, very. What also you see in India, and I'm sure this is true in other places as well, but what you do see over here is a hard edge at the end of forest. So if you see the Google Earth image on this slide, you can see that you can see a really clear outline where it says Bandipur and Nagarole National Parks and Tiger Reserves. You can see like a very clear outline of green. That outline of green is pretty much the outline of the forest. And you can see that there's forest on the inside and a very hard edge of agricultural land on the outside. So you have this juxtaposition of animals, of animal habitat, very close to where people are living and people are earning their livelihoods. But you also have a situation where animals need to move from one location to another. And often when they need to move from one forest to another, they need to move through people's areas. So this automatically, could you please switch slide? This automatically puts animals into shared spaces and shared landscapes. Could you switch slide, please? Thanks. So this automatically puts people into shared landscapes and puts them in contact with people. So in the previous slide, you could see that there were three people who were almost passively and in sort of an interested way, like how we might watch the morning news. They were watching a herd of elephants pass by an agricultural landscape. Over here, what you see is a group of kids who are clearly having a not so pleasant interaction with a herd of elephants. And so while elephants and other species, and I'm going to just use elephants over here from here onwards as an example species, while species like elephants use lands outside of protected areas and come into agricultural lands, plantation lands, their relationship and the responses that they have, that they sort of instigate from people, or the responses that people show towards elephants can be very varied. They can be very positive, as we saw on the previous slide, or antagonistic in some cases as well. Could you please switch to the next slide? What also happens is that from the elephant's point of view, it needs to move through these areas to access forests. And sometimes when it's moving through human use areas to access forests, its route is pretty peaceful, its movement is sort of safe, and it gets safe passage. For example, in the above, in the photo that you see above, it's getting safe passage through a tea plantation to access different forests. But in other cases, like you see in the photo below, there are a lot of people, there is a lot of noise, and it is a lot more risky for both the elephants and the people involved when the elephants are moving from one forest to another. Can you please switch to the next slide? So in shared landscapes, what is happening over here is that the elephants need to move, but as they move, they are coming in touch with people and interacting with people. And when they interact with people, that interaction can either be positive, and in which case the elephant gets safe passage through those lands, or it can be negative, in which case there is a cost of conflict, which is incurred on both people and elephants, and elephant movement is blocked, which means that a connectivity cost is incurred by the elephant as well. Can you switch to the next slide, please? This is a video just showing some of the interactions that people have. It won't come on the PDF, so you can just. It's showing the same thing that I just said. So clearly, when you're thinking about animals like elephants, and this is not just true of elephants, it's true of a lot of other animals. When you're thinking about, say, wolves or jaguars or coyotes, when you're thinking about wildlife which are persisting in human-modified landscapes, there are two things that we really need to think about. One is, how do they navigate fragmented landscapes? The second is, how can we ensure that there are positive human-wildlife interactions, or at least that there are no negative human-wildlife interactions? And to a large extent, we've thought about these things separately. Can you please switch to the next slide? Our solutions to these have also been separate. When we think about navigating fragmented landscapes, we think about securing corridors, we think about overpasses on roads. When we think of crop use, crop patterns changing. When we think about human-wildlife conflict mitigation, we talk about fences around protected areas or things like that. So often the solutions that we have for these two, what we see as conservation challenges, are different. But clearly, from what I just said, could you please switch to the next slide? From what I just said, movement of animals through fragmented landscapes, as well as their interactions with people, are very much intertwined. And not only are they intertwined, they have a relationship with each other. So the ability of an animal to navigate fragmented landscapes is dependent on it having positive interactions with people. And the interactions that people have with wildlife is dependent on these animals coming out into these sheds. Can you please switch to the next slide? And therefore, our solutions for these things also have to be intertwined. So if you have, for instance, fences around protected areas, this might completely stop conflict, but it's going to have very negative ramifications in terms of allowing animals to move from one forest to another. If you have land use planning, for instance, it can be a solution for both ensuring connectivity as well as for minimizing conflict. Could you please switch to the next slide? What also happens is that a whole slew of new questions come up if you're thinking about this, and if you're looking at connectivity on the one hand and conflict mitigation on the other hand together, because you can ask things like, how does human behavior influence animal movement, or how do factors or animal adaptations to fragmented landscapes change or shape human-wildlife interactions? And these can be very interesting questions, especially in changing landscapes. So in a recent paper, could you please switch to the next slide? In a recent paper, we put forth a framework and called it the connectivity conflict landscape interface, basically saying that there is a space where dispersing animals are going to come into contact with people and potentially cause conflict. And at the same time, conflict or conflict mitigation measures such as fences and barriers are going to stop connectivity. So in this schematic that you see, if you consider that the brown patches are forests, if you consider that the green sort of linear patches are movement zones, hypothetical movement zones. So there's obviously going to be variation across corridors in terms of whether they are good corridors or bad corridors, in terms of whether animals can move a lot or not move so easily. And the potential of the green corridors, the darker green corridors, is more than the potential of the lighter green corridors in this hypothetical schematic. But at the same time, you can have a perfectly good corridor with very, very high potential, which can be blocked because there is conflict in that particular area. So there's nothing structural which is stopping the animal from moving from one point to another over there. It's basically the responses of people to the animal, or the reciprocal responses of people and animals to each other. And that can then cause animals to either change their path, so that's a behavioral impact, and the animals are not able to move from forest A to forest B. But if you go a step further, it can also cause mortality. As you see in the photo below, that's mortality which is caused by an electric fence which is put across a particular corridor. So now we have a case where animals may move well, so you have well-connected patches, or they may not move well at all, so those are not well-connected patches. There may be well-connected patches, but then they get blocked because there's conflict. So that is where conflict is a barrier for connectivity. And when that happens, animals may just change their movement path. So that's just a behavioral barrier and a change in their movement. Or there may be a mortality impact where animals may die. Now, on the flip side of it, you also have conflict that's happening in all of these areas, but that is going to be shaped by where animals move. So how do you put all of this together in the same framework? Because all of this is happening simultaneously in the same landscape. The elephants are there, the people are there, the forests are there. We as conservationists want to manage all of these things together. How do we understand them together and deal with them together? This is the question that we wanted to ask. And if you could please go to the next slide. And we actually interacted with Rob Fletcher, whom many of you might know, and who was my advisor for my PhD. And he has recently developed a really exciting model called the spatial absorbing Markov chain, or the SAMC framework, where you can actually do this. So the SAMC framework models animal movement. But what it does is it says that, okay, I'm modeling animal movement, but at any point of time, there is some possibility that the animal may face mortality. At the same time, it also says that animals may move through various different paths, and it's going to choose the different paths based on how permeable the landscape is, or how costly it is to move through path A or path B. It's akin, for those of you who have done connectivity modeling before, it's similar to random walk models, or it's similar to circuit skip models. The only additional layer is that there is this ability to put in mortality or conflict-induced mortality specifically into the model. Could you please go to the next slide? So we applied this model to a landscape and elephant reserve in southwestern India. You can see the location in the landscape. And took 5 protected areas, and which is shown in purple over there, and did surveys around these 5 protected areas and asked people about 2 things. One is elephant presence in different areas, in different land use types. And the second is conflict incidents. So do elephants come over here? And if they do come, is there some conflict? And conflict we defined as any crop loss, or any property loss, or injury or death to people. All of that we combined into a single thing. We also said that the probability of conflict mortality, that is the probability of elephants dying because of conflict, is going to be directly related to just the probability of conflict that they face, and matched it to the levels of conflict that there are in the area. Could you please switch to the next slide? I won't go into the details of the modeling, but what we were able to do as a result of it was we were able to map connectivity across these 5 protected areas, and this takes into account the fact that there is conflict in these different places, and obviously there is higher conflict in some areas and lower conflict in others, and this model basically takes that into account. And you can also see that some of the protected areas are connected, but some of the protected areas, or at least the one protected area that you see up in the north, is relatively unconnected. You can also see that there are a few locations, or few regions which show up in bright yellow, and those are the regions which are really important clearly for maintaining connectivity. So these are important dispersal corridors. Can you please switch to the next slide? What we were able to do is also we were able to predict conflict, and this is now prediction of conflict, which is based on animal movement, based on where the animals move. We were able to say that these are the locations that are going to face the highest levels, or have the highest vulnerability to conflict. And you can see that it is again all sort of clumped around the source populations, especially the 2 source populations that are down to the south west. So these are the populations which have higher densities of elephants, so that completely makes sense. Within those areas itself, you can see that there are some locations that have higher incidence, some areas that have lower incidence. That's because of the land use change in these different locations. We validated these models, and they turned out to predict quite well. Can you switch to the next, please? So this is fine. We've predicted conflict and we've predicted connectivity, but the really important stuff or interesting stuff comes when we lay these one on top of the other. So what happens when you're looking at the 2 together? Because that's how it happens in real life. There are elephants in these landscapes. they are moving from one location to another. We want to allow them to move from one protected area to another. But we also want to make sure that they don't get into conflict with people. So we have to do these things together. Therefore, we have to predict them together. So when you overlay the two maps, one on top of the other, you come up with a map that looks something like this, and then you can identify a few different zones in this area. Could you please switch to the next slide? What you can see is that there are some sort of the lowest priority areas or the low conservation value areas are the ones which are in light blue. So these are the locations which are not really important for conservation because they are not important for connectivity in terms of connectivity and conflict. They are low conflict zones, not important for connectivity either. So these are locations that rarely see elephants and so rarely see conflict. In these locations, we might want to do some habitat restoration going into the future, but they're not really important priority locations. Then there are the bright blue areas, which are high conflict zones, but they're not important for connectivity. So these are locations where there may be farms that get hit once in a while by elephants, and people lose their crop to elephants. But these are not locations that are situated in any dispersal corridor. So in these areas, we can fence off the location, we can fence off the farm. They often may have like low frequency but high impact conflict or loss. So we can have things like insurance schemes. You then have the locations which are in orange. So these are the locations which are good for movement. So they're extremely good for connectivity but face low conflict. So now these are what we call secure corridors. These are the locations which are where these are like sort of your ideal locations. They are allowing connectivity in the landscape, but they are also not causing, the dispersing animals are also not causing any harm or cost to people. And as you can see, there are not that many secure corridors in the landscape. But in these locations, what you want to do is maintain status quo. But the most complex part of the landscape, and unfortunately, almost the most widespread of these four zones in the landscape is the green, the dark green. Now, these dark green is the connectivity conflict interface. These are the locations where it's extremely important for movement, so it's extremely important to allow elephants through, but there's also an extremely high cost to people. So there's high conflict, and it's also important dispersal corridors. In these locations, you can't just put a fence right across the area because that means that you can stop conflict in that location, but the elephants are going to suffer in the long term. In these locations, probably things like land use, changing of crops is what is the need for the hour. Could you please go to the next slide? So we also looked at a couple of examples of how this was supposed to be animated, but this is just to show that fences around PAs. So in this, I'll just run you through one example over here. We basically took conservation mitigation or conservation strategies that are currently underway in this particular landscape and look to see, okay, how that plays out in terms of our framework. And if you take a look at the protected areas that you can kind of see peeping out down below, you can see a light purple line along the boundary of the dark purple corridors. All of that light purple line is a fence of some form or the other. In large parts of the area, there is what is called a railway fence, which is the fence that you're seeing up in the top right corner. So these fences have been put at extremely high cost to stop elephants from coming out of the protected area. But as you can see, it doesn't always work very well. These fences are also put, if you recall from the previous map, these fences are also put along areas which were important for connectivity. So while the fences are talking to one particular problem, which is conflict mitigation, they're completely ignoring the other issue, which is that elephants need to move from one location to another, which is also why these fences are probably not working. The example down below of an elephant capture that you can see is also in a location which is in between, which is in the same elephant reserve, and which shows up from our model as a well-connected area, but also in the connectivity conflict interface. And it's a location where elephants were captured, thinking that it is a semi-isolated population. Our model clearly shows that it's not an isolated population. Once about 20 elephants or 30 elephants were captured, and more elephants just came in. So that also showed that this is not an isolated population. And so clearly on ground conservation actions can benefit from these kind of models and this kind of thinking of making sure that conflict mitigation happens alongside connectivity concepts. Could you please switch to the next slide? So just to say with this particular framework and example that in complex conservation landscapes where there are people and there are large animals like elephants, there are multiple ecological processes happening. There is interplay between social and ecological processes. And so we really do have to facilitate connectivity, but we also have to minimize conflict. So how do you do that in a particular landscape? So I want to take you now to a slightly different location, which is the Kaziranga landscape in Northeast India, where I actually currently am. Can you please switch to the next slide? So this, what you can see over here is the Kaziranga Karbi Anglong landscape. You can see in the inset where it is located in India. The yellow boundary is Kaziranga landscape. It is, sorry, the Kaziranga National Park. It's an extremely rich, very, very biodiverse park. On the north of it is the Brahmaputra River, which is an extremely wide river. And to the south, as you can see, is some amount of human modified lands, but also you can see the green, the dark green patches or the dark green locations, which is all Karbi Anglong. So those are the hills and the forests of Karbi Anglong. If you can please go to the next slide. So what happens during the monsoon season is that, or the rainy season, which will be like a couple of months from now, is that the rains will start, the Brahmaputra River will flood, and when the Brahmaputra River floods, it inundates a large part of Kaziranga National Park. So when it inundates a large part of the park, the animals have to move southwards. And by large parts, I mean, in some years, it's up to 90 to 95% of the park is underwater. So animals have to move down south. When they move down south, they have to move through human used land. And can you please move to the next slide? And some of these lands are paddy fields and human habitations, which are obviously much tougher to move through, and the paddy fields are also underwater. But some of these lands are tea estates. All of the points that you see, the orange points that you see, are centers of tea estates or point locations of tea estates in this landscape that we work with. And these are the large land holding tea estates in the area. So these tea estates are on slightly higher land, and the animals are able to move through these. And we have done surveys across the area, which say pretty much say the same thing. So tea estates serve as good movement conduits. Could you please switch to the next slide? Patricia, could you please switch to the next slide? This again is a video which will not show over here, but what you can see over here is that elephants don't really damage the tea, which is why they serve as such good corridor areas in terms of production land, and often move through paths which are there between the tea bushes. They also don't eat the tea at all. But what does happen, if you could please move to the next slide, is that if they encounter people in tea estate, then sometimes the interaction is positive and they are not really troubled by people and they're able to get safe passage and they don't cause any cost as well. But sometimes there are negative interactions, there's conflict, and their path is blocked. And in some cases, it can have pretty tragic consequences for people as well. So over here, it looks like the boys are just sitting and watching the elephants, and the elephants are just sitting and watching people. But that is a little too close for comfort. And if you can see closely, that boy who is sitting down there has a slipper in his hand. That slipper is aimed at the elephant. So this happens quite often in the landscape as well, where especially youth tease elephants, trouble elephants, go near elephants. If they move into, of course, other lands such as paddy fields, then they are chased away from there as well. Can you please put the next slide? So what we wanted to do is, obviously, so now we know we did ecological surveys which established that tea estates are good for animal movement. From what we have seen and what we have seen, we figured that people's interactions with elephants are really, really important for them to continue to use these tea estates. So we wanted to look at what human attitudes were towards elephants, but we also wanted to quantify it um, in a way that would be comparable across time. And I guess because my background is from a quantitative side of ecology, we wanted to be able to link it to spatial variables. We also wanted to separate notional attitudes from local scale attitudes. That is, everybody thinks that elephants are great, but we wanted to know if they think that elephants are great if that elephant is inside their compound. We also felt that from our generic interactions, and from reading of literature, we felt that there could be misreporting of attitudes. So people could be positive towards elephants, but not express it, or people may not be positive towards elephants, but because we would introduce ourselves as from an organization that's working in the area towards elephants, and most people knew that we were an organization that's working towards conservation, they may report a positive attitude when they didn't have one. So we wanted to be able to sort of sort out and parse through all of these things. So what we did, if you can please switch to the next slide, is we developed a Bayesian hierarchical model, which took attitudes towards elephants as a latent variable that people have, and basically modeled it as a binomial logistic regression, but had two levels of it, which was a notional attitude and then a conditional local level attitude. So you can be positive towards elephants notionally in an abstract manner. And then depending on that, you could also say, yeah, I'm happy with elephants in my land, or I don't want elephants on my land. We also put in the probability of people reporting it, misreporting basically. So subconsciously or consciously reporting that they had positive attitudes towards wildlife and they didn't have, and vice versa. Could you please switch to the next slide? So this is just all of that. And can you switch to the next slide? What we found was that, yeah, there's need okay, I'll just run through this. So we found that there were misreporting probabilities. So that was something that needed to be accounted for. Could you please switch to the next slide? We also found that people were extremely positive towards elephants in an abstract way. So 85% of people were like, yeah, we love elephants. But if you ask them, all right, are you in love with elephants when it comes to them being on your lands, then it drastically fell down by about 50%. And so that was a big thing, because now how do you translate that notional love for elephants to a positive attitude when it comes to sharing space, your own space with elephants? The other thing also is that if you, a lot of the negative interactions that come, so the photo that you see over here are people taking videos of elephants, and at this stage, they're too close to elephants for comfort. But this doesn't always come from a negative space. They're not trying to harass the elephants intentionally. Some of it comes from a positive space, because they're notionally positive towards elephants. They're excited to see elephants, and they want to get close to elephants and take photos of them. Can you go to the next slide, please? We also looked at, okay, what is it that drives these positive attitudes towards elephants, and found that to a large extent, it wasn't an indicator of forest health or any sort of ecological role, but it was sort of a deep-seated belief that elephants have an intrinsic right to stay and live in that region. There was also regional pride that, yeah, my district needs to have elephants over here. And there was recognition that elephants are sentient, intelligent beings. But obviously, on the flip side of it, a lot of people faced sudden encounters with elephants, which were damaging and which were dangerous for people. That caused negative attitudes. And in many places, they couldn't grow crops because elephants would come because of crop raiding from elephants. But by and large, there was a very positive attitude towards elephants, and that came from an intrinsic behavior or an intrinsic belief, and cultural beliefs that people held. Could you please switch to the next slide? So, what are we doing after that? Essentially, one of the things that we're doing now is to look at this response that people have towards elephants, and vice versa. What is the response that elephants have towards people? So, if people see elephants, what do they do? And depending on what people do elephants also change their behavior? And based on this, are there certain things that we can say can then show to people who live in this landscape and say, these are the things that you shouldn't do because this is what is triggering a charged behavior from elephants, and so on and so forth. So on the conservation side of things, we do a lot of awareness and engagement to try and discourage some of the behaviors that you saw and encourage the positive, or sort of like reinforce the positive attitudes and the positive ties that people have with elephants. In particular, you can see that a lot of the people chasing elephants over here are youth, are young boys. So especially, we're trying to focus some energy on moving them away from chasing elephants. And it's because chasing of elephants is what definitely increases safety costs of having elephants on people's landscapes. We also work simultaneously towards reducing financial costs of elephants, especially in terms of them raiding crops. Can you move to the next slide, please? Having said that, I want to step back to the connectivity conflict interface, and just to say that clearly from what we've seen over here, it's important to look at multiple processes simultaneously, and it's very useful to look at these processes simultaneously because they happen together and they happen in tandem. And clearly the fate of many animals, such as the elephant, is very much dependent on the interactions with people. But also I'd like to say that elephants are sort of symbolic. I've always thought are symbolic of nature, because with elephants as well as with nature, we if you ask in an abstract way, we all are in love with nature and we all love elephants. We just have some trouble figuring out how to live with them. Our conservation actions really need to focus on strengthening people-wildlife relationships. That's really important, very clearly. And especially because our action should be towards having conservation without fences, but also elephants and people are uneasy neighbors. We have to recognize that and deal with that issue as well. Can you please switch to the next slide? Also to say that we currently have the tools, the scientific tools, to be able to map these social ecological processes, and we have to use them to the maximum possible extent, such that we can make spatially explicit decisions, have quantified values across space, and have very justifiable decisions that we can then take in terms of our conservation. Next slide, please. Just a last point to make, that I've spoken about elephants a lot, and I think elephants are symbolic of and sort of epitomize the conservation challenges that we have across a lot of animals. But the same issues are true with a large number of species. They're true with other macaque species as well, other primate species. Some of these issues come up when you think about other impacts. So we are talking about conflict impacts, but there are other impacts such as roadkill. There are also conflict, for instance, the species that you see down on the bottom left is the dhole, or the Asiatic wild dog, that is rarely seen outside of protected areas, partly, I think, because of humans' companion species, which is feral dogs. And a lot of raptor species as well are sort of reducing outside of protected areas. So a lot of these issues are true for a number of other species that we deal with as well. Can you go to the next slide, please? And yeah, so that is it. With that, I'd like to thank all of you for listening. All of my colleagues and team members, a huge shout out to them. All of this work is thanks to all of them. Funders, Forest Department, tea estates, local communities whom we work with. And again, apologies for the technical issues, and for also taking more time than I should have. If you have any questions, I'd be happy to answer them.